Okay, so now we've learned about all of the forms of quadratic functions. The only one we have not talked about is a vertex form, which you can see on this paper is our middle format for quadratic functions. So first we're just going to look at standard form and factored form since that's what we're familiar with, and then we'll look at vertex form. So standard form is what we're used to, right? We've got f of x equals ax squared plus bx plus c. And I already know that if my function has a positive a value, then my graph opens up, which is what this is telling us. So if we have an a value that's greater than 0, we know we have a minimum, and we know that the graph opens up. So it looks like this. If a is negative, or if a is less than 0, then the function has a maximum and it opens down. So it would look like this. Factored form also gives me my y-intercept. So standard form also gives me my y-intercept. So I know, looking at standard form, that my c value, including the sign in front of it, is going to give me my y-intercept. So we know my y-intercept is just 0, c. The other information it gives me is the vertex in the line of symmetry. So I know my I'm going to start with the line of symmetry. So I know my line of symmetry I can find with x equals negative b over 2a. And then in order to find my vertex, I know the x value of my vertex is just the same as the x of my line of symmetry, but I also need to find the y value. So in order to do that, we just plug in whatever the x is of our line of symmetry into our original function and solve for f of x. So in a little bit more complicated form, we write it like this. Which just means my x value is negative b over 2a, and my y value, we're just replacing x in the function with whatever x value we got and solving for y. Now we're going on to factored form. Sorry, I misspoke earlier. So factored form is in this general format. So we looked at factored form with 5.8 and really earlier lessons when we were factoring functions. So we know if we have a GCF, we factor it to the outside here, and that gives me my a value. And I know that if a is greater than 0, then the function has a minimum and opens up. So exactly like standard form. We know if a is greater than 0, the function has a minimum and the graph opens up. So it looks like this, because that just is when a is positive. When a is negative, we know the function has a maximum and the graph opens down. I know more information from factored form, so I also know that the vertex is the 2 zeros being added together and divided by 2. So we haven't really looked specifically at this. I'll go into examples in the next video of looking at factor form for each of the pieces. But for right now, we're just going to write down that my vertex I can find by adding each 0. So when we set this equal to 0 and solve for q, and same with this, we add those numbers together and divide by 2. That gives me the x value of my vertex. To find the y value, you just need to plug in that x value into the equation. We also know, given this, that my axis of symmetry, or my line of symmetry, is also just the x value of our vertex. So it's p plus q divided by 2. And then I know that the y-intercept, we just have to substitute into our function x equals 0 for the y-intercept, and then we just solve for y. So we're gonna say our y-intercept we're gonna just substitute 0 for x and simplify. And then last but not least, we have our x-intercepts. That's different than our standard form. Standard form doesn't give me my x-intercepts, but I can easily identify them in factored form because they're just given to me right here. So normally if I'm in factored form, I would take this factor and set it equal to 0. I don't know why I did a parenthesis, but we're just gonna go with it. So x minus p equals 0. We add p to both sides and we get x equals p. And then same thing for x minus q equals 0. We add q to both sides and we get x equals q. So this just gives me my two x-intercepts. So I'm going to write x-intercepts are the x values when y equals 0. So we know that that is just what our p is and q. So we're just substituting in for the quadratic equation. And then lastly, we're going to look briefly at vertex form. This we have not seen before. My recommendation when you're given vertex form is to just write this out all the way and turn it into a form that you are used to using. But this does give us some helpful information. So we're just going to look at that in this video and then look at it more specifically in the next one. So vertex form gives me 3 pieces of information, just like the other 2. It gives me A, and I know if A is positive, the graph has a minimum and it opens up. So it looks like this. If A is negative, the graph has a maximum and it opens down. So like that, just like our other 2 forms. But I also know, given this, that my vertex is actually just directly given to me in the equation. So my vertex is just HK. So notice that this is a minus sign here. So you're going to take whatever the opposite of the H is. So pretend this is x minus 2. That means that H is just 2. And then for K, we keep the sign. And then just like we have for the other ones, the axis of symmetry is directly given to me because it's just my x value of my vertex. So the axis of symmetry is just H. And that's our 3 forms of quadratic functions. And we're going to go more in depth into an example of each of these in the next video.